Here's something a little strange. Drop a feather on the moon, a hammer here on Earth, a marble on Jupiter. Different worlds, different gravities, different heights. And yet, if you plot them the right way, every single one of those falls lands on the exact same curve. One curve. So, how does that happen? Because at first it looks like a mess. Every fall has its own gravity, its own starting height, its own clock. Plot height against time and you get a whole family of parabolas, no two alike. Nothing universal in sight. So let's slow down and ask the dimensional analysis question. What can a falling body even depend on? There are four suspects. The mass, which we'll call m. The speed, v. The height it falls, h. And the gravity pulling it down, g. That's the whole cast. Now, we translate each one into fundamental units: mass, length, and time. Mass is just mass. Speed is length per time. Gravity is length per time squared. And height is simply a length. That's the whole dictionary. And here's the first surprise. Look for the mass. That letter m. It shows up in exactly one place, the mass itself, and nowhere else. So there's no way to cancel it against anything. Can't join any dimensionless group. Which means the mass simply doesn't matter. Think about what we just did. Before writing down a single equation of motion, the units alone told us that heavy things and light things fall exactly the same. That is Galileo's discovery, dropped, so to speak, right out of the dimensions. So we're down to 3: speed, gravity, and height. Now watch the time. Both the speed and the gravity carry a time in them, so we can play them against each other to make time disappear. Take v squared over g. The times cancel, and what's left behind has the dimension of a length. And now the punchline of the setup. We've got two lengths. V squared over g and the height h itself. Divide one by the other and the length cancels too. What's left is pure number, no mass, no meters, no seconds. One single dimensionless group. We'll call it pi. Here's why that one group is so powerful. If there's only one dimensionless combination in the whole problem, then the physics has to reduce to a single equation in that one number. And the solution of a single equation is just a number. So pi has to equal a constant. And once pi is a constant, we just rearrange. V squared over gh equals a constant, so the speed is that constant times the square root of g times h. The speed grows like the square root of the height, no mass in sight. Dimensional analysis can't hand you the constant itself. That turns out to be root 2. But it handed you the entire shape of the law. There's a second way to see the same magic scale the equation of motion directly. The height at time t is 1/2 gt squared. Now pick a characteristic length, h0, and a characteristic time, t0, equal to the square root of h0 over g. Measure everything in those units. Substitute those in, and something beautiful happens. The gravity cancels. The choice of units cancels. Every trace of the particular problem just washes out. And the equation collapses to h star equals 1/2 t star squared. That's it. No g. No mass. No units at all. And now the payoff. Remember that fan of parabolas, every fall its own curve? Rewrite each one in star variables and watch. They slide. They stretch. And they all snap together onto a single universal parabola. Every free fall in the universe on the same line. So that's the quiet trick behind non-dimensionalization. Choosing your units cleverly erases the parameters, the g, the mass, the starting height, and what's left is the bare skeleton of the physics. Fewer variables, one universal curve, and the same idea works far beyond falling stones. Sometimes, the smartest thing you can do is just pick better units.